my laptop. So I said. Good afternoon, everyone. Let me set the laptop first. Okay, perfect. Okay, so let's start. Okay, first of all, I would like to thank ADGM for hosting ADML meetups today. It is my first time here. I remember when I met Gautier last year, and we discussed the status of ADML meetups and how we can encourage more people in Abu Dhabi to come and build an ecosystem and discuss ideas about AI, machine learning, that it will enrich our ecosystem, not only here in UAE, but also we can also reach the global and wider region, and we'll tell them about the innovation and advanced tech that we are doing here in United Arab Emirates. I would like to thank Rhoda for her commitment and dedication always through the email to enable us to come here today and present, and all the organizers behind the scene that set this meeting. Of course, I would like also to thank the audience today for putting their time to listen what is the breakthrough today in UAE and how we can collaborate and encourage and advance the ecosystem here in UAE. Maybe you can see at the beginning from my slides here, I chose that how we can advance the economy using large language model. So it is a big statement, but maybe you know that our focus today is how we can shift from oil-based economy to knowledge-based economy. And this will not be enabled unless we do breakthrough technologies. We enrich our AI ecosystem through industry, through startup companies, whether you are in the university, throw an idea and build an AI startup around it, whether it is using AI-powered solution or any other solution based on the advanced tech. And based on that, we will create an advanced ecosystem that not only enriched by the oil-based income, but also enriched by the knowledge that's coming from the people, and also it would advance our economy in the coming 50 years. One of the main things before we start, and I remember when as a co-founder for AI Cross Center Unit, maybe how many one knows here what is ATRC? No one, great. So ATRC, it is Advanced Technology Research Council, established by our leadership here in Abu Dhabi, and the main goal is we want to build an innovation research hub here in UAE, and we want to move from oil-based economy to knowledge-based economy, not only focusing on AI, but all the main pillars. We have Technology Innovation Institute, we have our sister company Aspire, and we have also Venture One. In Technology Innovation Institute, we have 10 research centers today. One of the main research centers that I am coming to, and I am speaking on behalf of them, is Advanced or Artificial Intelligence and Digital Science Research Center. We have also Autonomous Research Center. We have also Crypto Research Center. We have a Quantum Research Center. We have Biotic Research Center. We have Secure Research Center. And we are trying to tackle all the priorities sectors here that in Abu Dhabi we are focusing to provide a solution for it. We are bringing top-notch people working here in Abu Dhabi to provide a solution, but not only to publish a paper. This is not our goal. It is an applied research center. So at the end, we have a tangible solution that we provide companies like ADNOC, ADAR, ADGM. We have a meeting, for example, with ADGM also last week. They have a practical solution, so we come up with a solution based on the stemming industrial problem that we are trying to solve. Our focus today here, we will speak about large language model, and maybe it is maybe you didn't hear about it, but definitely you heard about ChatGPT. So ChatGPT, it is built based on the foundational model at what we call large language model. And ChatGPT today is built based on GPT-3, GPT 3.5, and also last week they released GPT-4. And why there is too much attention towards the large language model? Large language model, from what it says that I need a language. And our our unique human capability today as a human being is a language. I am using my language today to speak at you and to communicate with you. So how we can advance the tech center, how we can have a machine that we can communicate with them. So I have to enable these machines by a language. So we are building large language model, and it's large because before people they are using natural language processing, but it has limitation. So we moved toward large language model to enable this machine to talk, plan, reason as us as a human. What is large language model? So as I said, large language model, it stands how I can enable the machine to communicate with us, generate a text in a language, how it can summarize a text in a language, how it can provide me with a text that I am a human being, I am able to communicate with this machine. And as I mentioned also earlier, large language model are trained on large amount of text data. So how currently we are doing it? We web crawl all the internet, whatever is there from the information that people they are publishing in the internet. Of course, here is the unique thing is your large language model will be unique based on the uniqueness of the data and the high quality of the data that you are providing, and you are using it in training this large language model. So you web crawl all the internet. Of course, for example, ChatGPT is using English. Maybe it has the recent one, GPT-4, also it has the ability, maybe if you had the ability to experience with it, it supports Arabic, it supports Hebrew, it supports Spanish, English, German, and different multilingual capabilities. And why we are focusing on large language model, because once you are using this large language model and training it on this amount of data, our aim is to enable the generative AI models. So now, yes, it generates text, but tomorrow we can embed it, for example, in the financial sector. If we are talking here today about ADGM and they are focusing on financial analysis, I can train a specific use case on top of my large language model, the foundational one, about the financial reports that I am getting. And I want to create a financial analyst, a machine learning or chatbot that he is too much smart and he can be our human being machine thought partner, so he can enable me to analyze these financial report within a couple of seconds. Also, for someone who doesn't understand anything about the financial report, you can be in a meeting and they are speaking about a lot of things related to financial. You can put all of these input through this foundational model that has been trained on a specific use case related to financial analysis, and you can tell them, can you provide it for me in a very simple way, and it will. And how it start, of course, it started a long time ago that people, they want to go and move from the limited or the narrow artificial intelligence to artificial general intelligence. And one of the key pillars that we are tackling today in artificial general intelligence is generative AI and large language model. So people, for example, they are working on IBM, they developed Watson. People in Google and DeepMind and OpenAI also, they are focusing on large language model. Maybe you heard about ChatGPT, and it is an application that has been developed by OpenAI, and of course Microsoft, they almost invest at the beginning, they invest almost 1 billion in 2019. So it is quite a time in the market that people, they are trying to invest on this technology. And people, I think if I speak to you and I give this also this lecture before 1 year, no one will pay attention for large language model. I saw it by my own eyes when I was speaking or presenting Noor, which is the world's largest Arabic language model. People, they will say, okay, so what? It will summarize, it will give you, it will generate, it will write an article. But because of the launch of the ChatGPT, and within 5 days, you have more than 1 million users, people realize the importance that public, they are ready to utilize these large language model, and it makes them more efficient in their daily job or daily life. And if I will give you a summary about what the large language model they can do, of course, you can use it in content creation. For example, you can submit your idea and it can create for you a text based on your idea. You can submit, for example, an idea about a code. I want to develop a code to launch the website, and I want this website to talk about, for example, the financial statement. And these are my bullet points as a preliminary draft. And ChatGPT, for example, if we are talking about an application layer here can generate for you the code. So you can submit a code, or you can, for example, have a code and then you can ask this foundational large language model to build on top of it, or find if there is any vulnerability in this code, and it will do also for you. Also, we can use it for image generation, and this is very powerful. Maybe if you read about GPT-4, which was released last year, and read the technical paper, it can generate a text without even, for example, I can say, I am today with Rawda in the beach eating ice cream, and maybe the people they already saw Hillary Clinton with Barack Obama sitting on the beach eating ice cream, generating by AI. So this is the powerful of this this machine. It can generate humans. They are doing something without even being there, and it is real. So of course there is a bad side of it, and there should be a regulation that we have to put a governance plan for it. But it has this power, and if you look to the good side, you can generate a video, for example, for your kids. This is the good thing. For example, you can have a story for your kid, and your kid, for example, he likes to watch movie, or this is the best story, and the story, it is from your mind, but you cannot generate the movie for him, or you cannot also teach him, for example, about specific subject. If we are talking here about the education, for example, sector, there is a lot of information. You can feed this information and create a small video as a teaching video using these foundational large language model. Also, you can use it in task automation, for example, as a chatbot. For example, if you want to have a chatbot that it will enable you, and you can utilize it, for example, in oil and gas industry, based on the file and the reports that this company have, you can use it and train a specific use case on top of your large language model. You can also use it for code auditing, or you can, maybe if you saw a video about robot control, nowadays people, they are using these foundational model to also control the machines such as the robot. And if we look today to the LLM market landscape, you can see there are limited numbers of major players today. From Google, so Google, they have their own Lambda, and they release also their Bard chatbot after GPT. Also OpenAI, they have GPT-3. Now they already have GPT-4 released last week, and also A121 Labs. They have their own model, Jurassic, DeepMind. They have Google, NVIDIA. Also, they have the Megatron Turing large language models, and other also small startup companies. And when we speak about these large language model, there is two main key parameters here. What is the model size, and what is the training tokens? Before the chinchilla was introduced by DeepMind last year, there was a thought that the bigger the model that you have, the better robust analysis or output from your large language model will be. But it was not the case. Chinchilla from DeepMind, they came and they said, okay, no, it is not the case. You can have build a small model, but with more number of tokens, and based on the number of the tokens, and following the scaling law for that you have to respect when you are building this large language model, you will be able to have much better much better performance for your large language model. And as I said here, there is a lot of startup companies. They are currently utilizing this large language model, and you are based on the use case that I mentioned before. There is a lot of startup companies. They are using this foundational large language model, whether it is open source or using GPT-3 for text, for image, for audio, for video, for code, and you can build an ecosystem based on these foundational large language model. You can have each one of you today. I can give him an idea, and I can let him have a specific use case using our large language model, and you can start your business and help each other. And by this, we can create an ecosystem here in Abu Dhabi and globally as well. There are certain number of key considerations that you would like to consider when you are trying to build large language models. So either you have a license and you took a license from the big players or from us today because we already have our own large language model, or you want to try to build your own large language model. And the most important crucial part here is the data. What are the type of the data that you would like to use when you are building this model? Most of the large language models today, they are based on common crawl, so they are using whatever is available in the internet, and also they curate some of the data based on the scientific book and different resources for each company. What is the best model architecture here? And the revolution of large language model started because of the introduction of the transformers. So the transformers, this is a little bit technical, but I believe that we have some technical people here as well. They have different architectures that's based on the decoder, encoder, or decoder, encoder. You choose what is the best model that it will fit your use case, and you move forward with it. You have also to pre-process your data and your pipeline. What is the best tokenizer that it will enable you that it will be efficient to be utilized in your model? For example, we already built Noor, the largest Arabic language model in the world. But the main constraint that we face, what is the tokenizer that I will use for the Arabic language? For the English language, similar to GPT-3 or NVIDIA, there are many tokenizers that are available. You can go and read about them and try to use them exactly. But for the Arabic, we have to come up with a unique tokenizer that it will also provide me with the same output and the performance that I am aiming for. At the end, also you have to utilize the fine-tuning. So there are a lot of tasks related to multitask fine-tuning that you want to apply after building also this model. You want also to consider the evaluation of the model, and not only evaluating it by yourself. In the large language model community, we have certain type of evaluation metrics that we have to respect in order for us to compare with different large language model that has been developed by big companies. And currently, for example, Stanford University, they have their own evaluation. It's called HELM. So for example, Falcon, the one that we built here in UAE, we already submitted for them the evaluation, and they are the one who are doing the evaluation. And by this, you monetize all the evaluation around the world, and you make sure that there is fair evaluation among other big players also in the market. Also, one of the key considerations, how you want to deploy it. When you deploy it, can we use cloud-based? Do you want it to utilize it on-premise solution? And I think the main direction that most of the governments and the countries nowadays they will go through on-premise solution, because you don't want to exploit the data that you have, and you want to build a large language model that is fine-tuned based on the data data, proprietary data that you have within the company. So most of the companies nowadays, the big one, they will try also, I believe they will come here to UAE to sell their large language model. But the main thing that we should consider that we have to build our own on-premise solution to keep the privacy and maintain the privacy of our data. And of course, one of the main things which is still not solvable also in the machine learning and AI domain, the explainability. So why these machine learning algorithm they are working, how I can explain the outcome of these models. And this is, there are dedicated groups around the world today. They are working on explainable AI issues. And one and the last but not the least, I think the bias and the toxicity, which is the main constraint here, because maybe you already experienced the use of GPT-4, but still, although it is the most advanced one around the world, still it provides you with a misleading information. Still it is biased in terms of certain social manner. Still it provides you with the hallucination impact. So you have also to consider how you can build your own large language model into and put into the consideration the bias and toxicity level of your model. And what are the main things that we try to focus and put here in UAE? So why we need to build it? Because we know that they are the key players here in the market, whether it is Anthropic, DeepMind, Google, Microsoft, OpenAI. But the main challenge is on-premise LLM and how we can train and have our own LLM, because I can have a license from different companies. However, I will not be able to customize it. So when I build my own LLM here in UAE, I have full access to it from the background and the foreground IB, and I can customize based on the needs, whether it is government entity, whether it is healthcare entity, whether it is financial sector, and so on. And who will benefit from our work here, for example, in UAE? So it is not only UAE, because now we are competing and among the top players in the world nowadays. There are different use cases. You can use it as a conversational AI chatbot, whether you want, for example, to use it to provide you certain information and you don't have any knowledge about it. You can ask and build a chatbot based on a use case using this large language model. You can have it also for writing assistant. The journalists, the people who are working on the media, they can utilize these tools today to write an article for them, or at least a draft about certain topic, and then based on their expertise, they can take it and move it forward. I don't see this technology is threatening us, but also it will enable us to minimize the time that we usually we take, for example, in drafting email and writing an essay about certain topic, or only providing us with the basic knowledge that we would like to have before entering any, for example, meeting that we don't have the knowledge for it. Also, we can use it as a powered search engine. For example, today if you go to Google, you will use it, but it will provide you with a certain type of inputs based on what is the question that you ask Google to provide you. And I believe with the release of ChatGPT last year in November 2022, Google, they already raised the red flag. And that's why they worked on their own Lambda. They already have Lambda, but they were not aware about the effect of this large language model when it will be released in the market. And they have their own Bard chatbot. And I think that the game that it will come also soon, how we can integrate, and it's already coming. It's already there, available in the market, but it needs people to work on it, startup companies to provide the solution, how we can integrate the power of the large language model in the search engine that we have it today. And from the end user as well, you can have it as it will support you in maintaining, for example, certain quality. So based on the trained specific use, let's say a case that you have, I can give you example. Let's go back to the financial, since we are on the ADGM, for example. In ADGM, and I'm assuming here because I didn't work yet in ADGM, but let's say, for example, in the legal contract, usually there are a certain template that when you start, you have to consider these key things and key messages that all the lawyers, whether they are beginners or they are seniors, they have to consider always 1, 2, 3, 4, 5, 6, and extra. So we can submit all of this information and train a specific use case as a legal counsel that it will help any lawyer here working on ADGM. I'm giving you an idea, huh? So you have to come back with a business for me. Okay. And of course, the main thing also, you can always use it for the research purposes. You can also use it for drug discovery, for example. If you was able to provide the healthcare, for example, they have their own data. They can always submit their own data. They have it through the patient or certain diagnosis, and also you can utilize a use case for healthcare domain. And also we can use it in the drug discovery. If I was able to, for example, discover what is the next protein molecule that I can use for X disease, I can submit these data, but I will not ensure that this large language model, they will give me the right answer. But it will help me to think, and maybe it will lead me with an idea that I can maybe take 3 months, 4 months to have it. Okay, so here I didn't present all the technical detail for our Falcon because of the confidentiality yet. We are working on releasing the technical paper, but maybe for the people who don't know, Falcon, it's only the mini version. There is the max version that it will be released by the end of this year. So I cannot release all the technical information here for Falcon. And Falcon, we chose it as a 40B also. As I mentioned before, it is not about the size anymore. You can have a small model trained on more number of tokens, and then you have much powerful model in compared with GPT-3, Chinchilla, and so on. And also the thing that you have also to consider, what is the high quality that you have and you inject in building your large language model. So here, for example, we did a lot of experimentation and we maintain the curation of our data set. And maybe here you can see, this is just a simple summary about the quality of our data that we used. We did our own refined web data, so we command crawl all the internet. Also, we have a certain X% of the curated data that we inject in developing our large language model. And you can see here the accuracy on the performance of zero-shot performance for our refined web data in compared with GPT-3 and the BILE one. And this is public also information. So LLM Falcon, as we mentioned in the press release. So this is Falcon. This is Falcon LLM, and you can see here the performance. It's outperformed GPT-3, although it has less number of training compute budget. However, we was able during a cheaper training cost and smaller compute budget to outperform GPT-3. And again, I said this again and again because it is no more about the larger number of the parameters. It all changed since last year with the introduction of the DeepMind paper. And here you can see, for example, there are certain tasks that I mentioned before. Also, you have to consider it while evaluating your model. And here you can see also Chinchilla. So ours as a Falcon LLM outperform Chinchilla, and it has similar performance as well for BALM 62 billion model. And this is thanks for our data pipeline. So our engineers, they worked on refine the web data and make our data pipeline due to the filtration, the tokenizer, and also the model architecture played a vital role in outperforming the current state-of-art large language model. And here, for example, I can show you similar. I can show you here, for example, small outcome from our Falcon LLM 40B. And here I asked Falcon LLM to generate for me a text, and I told him, can you please write for me about UAE sets out a blueprint for next 50 years? And you can see the quality of the output of the prompt using Falcon LLM. And you can see here that it gives me a very powerful, and I am glad because I was not really expecting the performance of Falcon LLM 40B. I thought that the big one will be much better, but we were amazed that we already outperformed the state-of-art GPT-3, Chinchilla, and BLOOM 62, and it provides us with a very robust output in terms of the text generation and the quality of the output as well. Here also I gave him and asked him to summarize for me the UAE vision in 2021 and how we can move from oil-based economy to knowledge-based economy, and it was able also to give me a very thoughtful summarization to the point. And here I did conversational, although we didn't do any human feedback yet, but our Falcon LLM have a very good foundation for starting to enable us to build chatbots similar to ChatGPT. And you can see here, for example, I was asking our Falcon to provide us with a recommendation for a few sci-fi books, and then I asked him about specific author, and he was able also to give me his idea about, or his thoughts about this author, Arthur Clarke, if you heard about him. And then I asked him about the movie, and he gave me his opinion about the movie as well. And we also have multilingual capabilities. So we already injected 10% of our data was multilingual. So we chose also the one that has similar English characters to the English model. So we tried to prompt him in English, France, also Dutch and Spanish. And our Falcon LLM was able to provide us with the correct answer, even if we are speaking with him with a different language. And I believe this is the video. How we are managing the time. Is it okay? We have 5 more minutes. 5 more minutes, okay. Okay, tamam. No worries. So these are the same question, and they want me to stand because they want to have a photo while I am here on the screen. Sorry. But then how I can? Okay, take the picture and then. Okay. Okay, let me focus. Okay, so the second thing here also, we already discussed Falcon. So now we will shed the light on Noor, and maybe you heard about Noor. So Noor, we started working on Noor in last year, and it was released in April 2022. And of course, if you were also lucky, maybe you saw the first published article in the Etihad newspaper that written 100% completely by our developed large language model. And at that time, the main idea was, before also working on Falcon, so Noor was our stepping stone project to the era of generative AI and large language model. And the main focus is we want to preserve the language for us as an Arab region, we saw that the most people, they are concentrating on English language and how they can utilize it. But as I mentioned before, the language that you train this large language model, it will be the language of the technology in the future, because these large language model will be utilized in all the use cases, in all the disciplines, whether finance, healthcare, education. So it is very important to train large language model that's only focused on the Arabic content. However, as I mentioned before, still we have the main key players in the market, but they are not providing it with Arabic. Even though if it was provided in Arabic, I tried a ChatGPT before 2 months, so I didn't try it yet with a GPT-4 powered foundational model. I asked ChatGPT in English, using the English language, to provide me with the correct answer. And I asked him again with the same question, but using an Arabic language, to provide me with incorrect answer. So it has misleading information. That's why now also we are developing Noor version 2, larger than the Noor that has been released last year. And the main focus also is we want to strengthen the position of the Arabic in the worldwide. And not only we were the one who are interested. So many people around the world, they are interested on utilizing Arabic, not only in the Arab region, but worldwide. We have people coming from France asking about how they can have a license for Noor to utilize it in different use cases for them. Of course, what we are trying to do now, we want to build the world's most powerful, not only the largest or the best one, powerful Arabic large language model that will enable us to be utilized, for example, in the education, for example, in the school. If we are speaking using Arabic language in the government entity, if we have our emails, for example, in the entity utilizing the Arabic language, I can use Noor as a foundational model, and I can build a use case, for example, to provide me, for example, default, like let's say, generate an email as a response based on the input that has been provided in Arabic language. Our solution today, we are focusing on how we can advance the Arabic large language model, but there's a certain point that I should mention here. Unfortunately, the Arabic content in the internet is only 3%. So when I started this lecture, I mentioned that most of these large language models, they web crawl the internet. So even if I will web crawl the internet for my Arabic language, I will get only 3%. However, we have almost more than 141 million users today. If they can hear me, they have to start writing Arabic. If we want to preserve our Arabic language, if we want still to communicate in the future with our machine, because this machine, believe me, still you didn't see it, it will be empowered in your phone. Alexa will be powered by large language model. Today it is not. But tomorrow it will speak to you, it will give you an answer based on this large language model. Do you want to communicate with Alexa using Arabic language? Then you have to enrich the Arabic content today in the internet, whether you are a scientific, whether you are in the government, how we can collaborate today to enrich and have more robust, high quality Arabic data that we can utilize in building this generative AI model. And the same use cases that I mentioned before, it will be the same for Arabic language. You can adapt this large language model in on-premise solution. You can utilize it for education. You can utilize it for generating a book, for example, using the Arabic language model Noor. We already have our Noor already wrote an article about the economic growth and the climate action, and it was 100% generated by Noor, and the quality was very high. However, because of the limitation of the content of the Arabic, it is very clever in certain subjects. but then because of that we have a certain limitation in specific areas. Still, if I start to prompt Noor, and maybe some of you try to utilize Noor or test Noor last year, still they have we have to advance this large language model in Arabic if we want to utilize it in the future in our machine and our daily life. And here I will show you, for example, some of the maybe chatbots because of the limitation. So what is the powerful about when you have a chatbot? Now it is easy to explain, because last year when I was explaining the powerful of these chatbots, no one believed me that we need these chatbots. But ChatGPT, thanks to ChatGPT revolution, now everyone wants to have these chatbots in their daily use. So I started to use Noor, and Noor was completely, it was not built on GPT-3. This is very important because I receive always a question that it has been built on GPT-3. It has been built completely from scratch, considering the model architecture, the data pipeline from end to end, and until utilizing the Arabic content. And you can see here I am asking Noor to provide me information about UAE, and I apologize for the people here that they don't understand Arabic language. But then he started to tell me, I know everything about UAE. Then I asked him, what is the capital? Who is the founder? And what are the other Emirates? And this is very important thing you can notice if you go and today in the search engine and you ask Google, for example, who is the founder? He will not provide you with any answer, or maybe he will be confused because you didn't say who is the founder of United Arab Emirates. When you try to train this large language model, it is like a human being, like we are sitting together in a meeting today, and I already started the conversation about large language model. So it will, any question related, or it will come later, your brain as a human, you will relate to the subject that we start at the beginning. So at the beginning, I spoke to Noor, and I told him that I need to know information about UAE, and it already have the context of our subject, and it will enable me to be my thought partner. So any question that I would like to throw on Noor, it will provide me with the answer. And I think we already done here, but here, for example, this is the data processing pipeline for the people who are interested on the technical information. Okay, so still you have to consider how you can extract these data from the web, how you can consider the filtration process, what is the best tokenizer. Nowadays we are trying different tokenizer to build our second version of Noor, how you can also reduce the duplication, because when you come and crawl the internet, there is a lot of duplicates in the information. So what's the best technique that you can utilize to remove the duplication in your curated and web crawl data? And this is the first released article about Noor. It was published last year in November 2022 in parallel with a media worldwide congress that has been held here in Abu Dhabi. And by the end, we conclude our presentation today. But the main key message here that we would like to have, maybe it is very technical presentation for you, maybe it is very like straightforward because you're already working on this domain. But the importance that you have to take today, that we are today in a race. It is not about the race of a human or the race to be the best. It is about the race of how we can enable our economy here system in Abu Dhabi. So if you have an idea and I have an idea, if I develop large language model and you have a use case that you can utilize based on that large language model, we can have an ecosystem that starts today, and we can collaborate with each other, and by this we drive the economy that we are aiming for, of course in parallel, of course with the focus that in respect with your domain with generative AI. Maybe people, they will say no, it is misleading and it will take our location or job. Believe me, if you think that it will be a thought partner that you can utilize it in your daily work, in your daily life, you will provide a more efficient and accurate result, and also you will be relaxed because you will be able to achieve this one. Yes, we need governance, yes, we need regulation, but this, I think the time will come, and the people working on the government, they are working to utilize the regulation for these large language model. And thank you for being here today and listen to our presentation. Thank you again for ADML Meets Up and ADGM Academy for hosting this presentation. Thank you. Do we have a Q&A?
Dr. Bassam. Thank you, Dr. Bassam, for the very insightful and interesting presentation. Actually, we received a lot of interesting questions through the chat box for virtual attendees, and I'm sure some of our physical attendees will be asking some questions. So we will be taking all the questions at the end of the presentation due to the time constraints. Thank you, Dr. Bassam, again. Thank you. So for our second speaker for today's event is Vincent Zuni-Kind, who will be speaking about EMNLP 2022 in Abu Dhabi and the key takeaways.
So last year in December, I attended the EMNLP conference that was held here in Abu Dhabi. So that's the empirical methods in natural language processing. And I will present some key takeaways from that conference. There will be 3 parts in that presentation. In the first one, which is not really related to the conference, I will present some general notions about NLP. In particular, so classical NLP, the notion of vector embedding, some network architectures, in particular the transformers, and a list of problems that can be solved by NLP. In the second part, I will present some of the topics very quickly that were presented at the conference. So that will be very broad but very shallow. I will just throw ideas with a few references, but those ideas will be unrelated to one another. So if you don't understand one, you can still continue to listen. And in the last part, which will be just 2 slides, I will present a few Python packages that you can use if you want to actually use NLP with your own data, with your own problems. So that was in December, just after ChatGPT was released. So everyone was talking about ChatGPT. So when I prepared that presentation, I asked ChatGPT to write the introduction for that presentation. The English is extremely correct. The structure of the answer also surprised me because it is well structured. There are 3 different parts: a definition of NLP, a list of problems that can be addressed by NLP, and some of the issues posed by NLP, but it's not factually correct. In particular, when it tries to list the problem, to mention some of the problems posed by NLP, that's the last one in bold. It says that current NLP models cannot generate human-looking English, and the ChatGPT is the example that it is no longer a problem. The main problem, one of the main remaining problems, is factuality. We don't really know if the output of those models is the truth or not. So if we want to process text with a computer, with machine learning models or with deep learning models, the first step is to deal with the text, because text is just a sequence of characters and not numeric data. So there is some pre-processing to do. You first have to split the text into a sequence of words or a sequence of tokens. The tokens can be words, but they can also be pairs of words or triplets of words, and there will be slightly more information. One of the first approaches was so another issue is that the text is actually a sequence, so there is some ordering of those tokens. And one of the first approaches to NLP was to forget that order and just consider the text as a bag of words, an unordered sequence of words. But we need to convert that into numbers in order to give the text to machine learning algorithms. The simplest approach is one-hot encoding. For each word or for each token in your datum, you consider a vector, so a vector, so a basis vector. But that poses two issues. The first one is that when you do that, all the words have the same importance, but some words are more informative than others. For instance, words such as dim, a, beam, tomb, from, and so on, those words will appear almost everywhere, and they don't give any information, any relevant information about the nature of the text. So you want them to play a less important role. And another, so you have the words that appear well, there are two things that you can take into account. First, how frequently a word appears in a text. If a word is repeated often in a given text, that may be important for that text, and whether words are repeated a lot across texts. So we can define two quantities called term frequency and inverse document frequencies, and then combine them in various ways in order to give weights to the words. So there are different ways of computing those weights, different ways of actually normalizing those two quantities. The two most common ones are called TF-IDF and BM25. Intuitively, they are the same. It's just they normalize the data, they rescale the data in a slightly different way. Another issue with the one-hot encoding, even if we add the weights, is that they consider that two different words will just be different, but we don't take into account the fact that they could have a very similar meaning. For instance, cat and kitten are two different words, but they are very similar. But cat and idea are very different words. So we don't want. We would like the distance between those words to be different. So one way of doing that is by using what we call the word embeddings or vector embeddings that replace each word with a vector. There are several ways of defining those embeddings. I have listed them at the bottom of the slide. I will not explain here how they are computed, but they are readily available. That's an example of those word embeddings. So what I did was just take the name of a few animals, computed the word embeddings. So that was, I think that was word2vec. I end up with vectors in 300-dimensional space, and then I computed the PCA, the first two principal components of those vectors, and I obtained that figure. So we can see here that we have a clear separation between domestic animals and the wild animals. And if we add words that are not animals, here I have added a few means of transportation, they end up clearly separated from the rest of the animals. So that shows that those word embeddings do capture, indeed, as we wanted, the semantic closeness of the words. When we once we have those, when we have turned the text into numeric data, we can start to try to give it to machine learning algorithms. Most of the time we'll use something like a neural network, which will take the input as typically as a vector, multiply that vector by a weight matrix. So that means apply a linear transformation, then apply an element-wise nonlinearity, and a neural network, a standard neural network, just repeats that again and again, perhaps dozens of times. And we have two types when we deal with text. We will have two types of parts in the neural networks. Either the encoder part, which starts with text and ends up with a vector or a number. So the vector could be directly the output of the model, or it could be some latent representation of the contents of the text. And you have you can have also a decoder part that starts with a vector. So typically the latent representation from the encoder, and we'll try to transform it into text. So in picture, the encoder decoder infrastructure could look like that, but there's something that is hidden in the picture, namely the fact that text is not just a token, not just a word, but a sequence of words. So if so the sequential information, we can end up with an infrastructure like that. So what you have here is the input and the output. The encoder part is on the left and the decoder part is here. And you have, so at the beginning, you start with the first token. You compute a vector embedding of that token. You compute after that some latent representation of that. So for the moment, it's that token. After that, you do the same thing with the second token, and you will combine its latent representation with the previous latent representation. And as you progress here, what you have in those boxes is the latent representation that summarizes the information in the sentence up to that point. And here, that's the end of the sentence, and we can do the same thing in reverse in order to generate the output. At each step, we add the so the information that we have already generated and combine it with the information from the input sequence. So in each of those boxes, we have the information about the previous sentence, but also the information about the sentence that has already been generated. What I presented so far was a slightly old-fashioned deep learning. So that's called an autoregressive model because it processes the tokens one by one. But you may have heard a lot about the attention mechanism or about transformers. So in one or two slides, I will try to explain what it is. The attention mechanism is just a differential hash table. So a hash table is what you call a dictionary in Python. So that's just a correspondence between a set of keys and a set of values. And the way the attention mechanism works is with three inputs. So you have a query, so that would be typically a vector. You have a set of keys, so not a single key, but a set of keys. So typically that will be a matrix, and a set of values, again a matrix that corresponds to those keys. If everything is one hot encoded, then just by taking the product of those matrices, of those vectors and matrices, you will end up with the value that corresponds to the query if the query was in the set of keys. And what the attention mechanism does is that it generalizes that more or less by keeping the same formula. The only difference is that we add a softmax in the middle in order to have probability distributions, but we replace the one hot encodings with probability distributions. So in short, the attention mechanism is just like a Python dictionary, but it has been made differentiable, and it can take as input something that is not just one hot encoded, but that could be a dense vector. So here in that presentation, the query was a single vector. In practice, when you use it, you will not use it with a single vector, with just one vector at a time. You will use it with for several queries at the same time. So the input will actually be a matrix. And the formula looks, well, part of the formula looks like that. You have here each row that corresponds to a different query. Well, no, sorry, each row here that corresponds to a different query. And here you have the correspondence between the queries and the queries and the keys. So if the queries correspond to the different tokens in a sequence and the keys to the different tokens in the same sequence or another sequence, that gives you a correspondence between the two sequences. Which part of one sequence is most similar or most relevant for which other part of the other sequence. So that matrix is called the attention matrix, and if you want to interpret what a transformer is doing, this is usually what you look at. So that was the attention mechanism, just a differentiable hash table. And the transformer is almost the same thing. The transformer is just the attention mechanism with a lot of implementation details. I will just highlight two of those implementation details. The first one is the positional encoding. In what I presented about the attention mechanism, there was no ordering. The ordering was just the ordering of the rows of the matrices or the columns of the matrices, and you could change that order. That would not change anything. But we want to keep the information about the order of the sequence. So we can add as part of the input the position of each token. So it means just adding one coordinate that will be, for instance, something between 0 and 1, 0 at the beginning of the sequence and 1 at the end of the sequence. So that's a simple positional encoding. There are several variants. You could have something that is multidimensional, for instance, a Fourier basis, or you could even have a learned positional encoding. The other important implementation detail is the self-attention. When I presented the attention mechanism, there were 3 inputs: the query, the keys, and the values. In practice, quite often, those 3 inputs will be the same, or transformations of the same input. So the query will be some transformations of the input data, the keys will also be another transformation, and the values will be another transformations. And there are a few other small implementation details in the transformer. So that summarizes the transformer architecture that's taken from the paper. If you want to use transformers in your code, that's readily available, for instance, in PyTorch. So on that slide, I list a few of the problems that can be solved with NLP. The first one is regression problems. The input is text and the output is a number. That could be, for instance, sentiment, computing the sentiment, positive or negative, of a sentence. A slightly related task is classification. Here the input is a sequence and the output is a class. So that could be things like named entity recognition that tells you for each token if it is the name of a person, the name of a place, the name of a company, and so on. Natural language inference takes as input 2 sentences and tells you whether they are logically related, if one is a consequence of the other, or if there's a contradiction between the two. You could have also some non-supervised learning. In topic modeling, the input is a set of sentences or a set of documents, and you end up with a clustering of those sentences or of those documents. You also have the embeddings. So that's another form of unsupervised learning. I've already mentioned the embeddings for the tokens or for the words, but you can do that for whole sentences or whole documents. And I think that will be mentioned perhaps in Gautier's talk slightly after. And you also have NLP tasks where both the input and the output are text. So that's what was mentioned with the chatbot in the previous talk. You have things like machine translation, question answering, summarization, and so on. So that ends the first part. That was a slide of a broad overview of some random topics in NLP. I will now talk about the conference itself. So the papers in the conference were organized into different topics. I could not attend everything because most of the sessions were taking place at the same time. I've only attended those that were highlighted. So if you talk to someone else who attended the conference, he may have had a completely different experience. Just before the conference, there were a few days of tutorials, and I have attended 3 of them. So about abstract meaning representations, causality, and non-autoregressive models. I will mention a few words about them later. And in parallel to the tutorials, there were also workshops on those topics. But since I was attending the tutorials, I did not attend any of those. So even though I attended the conference, that was almost 1 week, I have missed most of the conference. There were also a few keynotes. One was applying ideas about language to comics, showing that in comics, in American comics or Japanese manga, you could decompose what was in the image in the same way you decompose sentences with almost grammar rules or expressions that were repeated. There was a keynote by Hugging Face in which stage, they presented some of the tools they develop to monitor the quality of language models. And there was also a talk by Gary Marcus, whom explained that scaling is not all you need. So you do need some large probabilistic model, and that's what we currently have. But you may want to combine it with something more formal, something that will be able to do some formal reasoning. Among the many presentations, so many of the presentations fell in one of the following two categories. Either the researchers could not find a data set for the problem they wanted to solve, so they created a data set, and they were happy with the data set they created. Or in other cases, they were unhappy, unsatisfied with the evaluation metrics that are commonly used in NLP, and they tried to devise their own evaluation metrics. And usually they were not happy with the result. So that remains an open problem. We don't really have a good evaluation metric, in particular for all the text generation tasks. So some of the talks were about summarization. There are two types of algorithms to summarize a text. So the input is a long text, and the output should be a short text that summarizes the long text. The abstractive summarization algorithm start with the long text, try to compute a latent representation of that long text, so that would be a vector in a high-dimensional space, and then convert that latent representation into some text, the desired summary. One problem is that by doing so, we may forget some of the information present in the input, and then try to invent or reconstruct the information that has been forgotten. So you could end up with things that were not that are in the summary, but that were not present in the initial text. That's usually called hallucination, and that's one of the main problems with language models. The other type of algorithm for summarization is extractive summarization. In this case, we take the input document sentence by sentence, and for each sentence, we use a classifier that will tell if the sentence should be kept in the summary or not. After that, however, we end up with a long list of potential sentences to build the summary, and there is some repetition in those among those sentences. So we need to remove the duplicates in order to have a more concise summary. In order to remove the duplicates, some of the papers use something called determinantal point processes. So the idea is to take all your sentences, compute the similarity between those sentences. So you end up with a similarity matrix with one row per sentence and also one column per sentence. And you can sample, so determinantal point processes sample, give you a probability distribution on subsets of those sentences. So if you sample from that process, you end up with a subset of sentences. So the first time I saw that, it was a bit difficult for me to understand why that would give a diverse set of sentences, but it's clearer if you look at an example. So let's imagine that you have three sentences, and this is the similarity matrix between the three sentences. So you have sentence A, which is different, and sentence B and C, which are almost identical. And if you compute the determinant of the subset of the submatrices of that big matrix, you notice that if B and C are both included, then the determinant is 0. So that will not be selected. And for the others, then in this example, they will be selected with the same probability. Another task is question answering. So here again, there are two types of algorithms for question answering. The first one is parametric. So that's the normal neural network. You give the sentence as input, and the neural network does its magic and gives a sentence as output. So here the answer, all the knowledge is hidden in the parameters of the model. And And you can have the same hallucination problem as before, because you don't really know what is in the model, and the model may reconstruct some knowledge that was not present in the training data. The other type of algorithm for question answering is non-parametric. In this case, it proceeds in 2 steps. In the first step, the algorithm takes your question, converts it into a query for some external system, for some external database, for some knowledge base, and then it queries that database. So that could be converting text to SQL and then running the SQL text. So the data, the information in this case can be stored in a knowledge graph. We don't have the hallucination problem that I mentioned before, because you just have the knowledge that was put in the database. Quite often the data is represented as what are called RDF triples. So these are relations between entities. I like to see that as subject, verb, object relations. So it's a bit like a sentence. You have 2 entities, the subject and the object, and a relation with different types that is represented by the verb. So here is an example of RDF data. So I use data from DBpedia. So that's data that has been scrapped from Wikipedia. And that can be represented as a graph. So you have the different entities as boxes and the different relations as arrows of different colors. Quite often people, at least in NLP, use a language called Sparkle to query that kind of database, but I've never seen it used in practice or outside NLP. So if you want to play with that kind of thing, you may also want to look at other query languages for that kind of database, such as Cypher or Gremlin, which may be more widely used, or at least more widely used outside NLP. Another problem that question answering systems have is that quite often the question is complicated and the system will struggle to answer that question directly in 1 step. So for instance, if we ask what was the first novel that Charles Dickens wrote, the system may not have the answer immediately. It may have to first get a list of all the novels by that author, then check the date of publication of each of those novels, and then do some sorting in order to find the minimum date, and then get the answer. So there might be several steps, and in some situations that can be slightly more complex than that. And question answering systems can struggle with that. There are 2 ways of addressing the problem. The first one, and that works well apparently with ChatGPT, is just to ask the system to give more explanations, not just to give the answer, but to give all the steps that it used to derive the answer. And another solution would be to do that yourself in 2 steps. First, ask the model what intermediate information it needs, and then for each of those intermediate steps, ask the model to solve those intermediate steps. So I think that's more or less what Gauthier did when he used ChatGPT to write a book. First, give the title ask for the title of the book, then the title of the chapters, then the title of the sections, and so on. So you could use that for multi-step reasoning. Another type of problem that question answering systems struggle with is numeric questions. So they are very good with text, but not good with numbers. So there are 2 ways of addressing that problem. The first one is to pre-compute all the quantities that may be needed. So if you have a table of numbers and want to ask questions about the table of numbers, you can compute the sum of all the columns, the sum of all the rows, the average of all the columns, and so on. And you give all those pieces of information to the model. So you do the computations beforehand, and you let the model choose which of those numeric quantities is the most likely answer. And the alternative would be to ask the model which quantities it needs. So that would be again a two-step process. First, you ask the model, in order to answer that question, what quantity do you need? It may answer something like the average of the numbers in the second columns of the table. And after that, you would compute that with some other system. You could also ask perhaps the model just to give code to do the computations and then run that code. Information retrieval is related to question answering. It's slightly different. In question answering, you have a question which is text and the answer which is text. In information retrieval, you have a question, but you also have a corpus of documents that could be all the web, and the answer should be not the answer to your question, but the document that contains the answer. One way to address that kind of problem is with a cross-encoder. You build a neural network that takes two inputs, the query and a document, and tells you if the document is likely to contain the answer to that query. And for each query, you would have to run that on all your database. So that's not very scalable, especially if the set of document is everything on the web. An alternative is a dual encoder. So here you encode separately the query and the document, and then you do something very simple, such as compute a scalar product or compute a distance or something that is almost immediate like that. That would tell you if the document is likely to contain the answer to the query. And here, since all the documents can be pre-processed, that is much more scalable. But the problem is that it does not work as well as the previous approach, because the way the query and the documents are compared is extremely simplistic. So instead, you can do something in two steps. For the first step, you would use a dual encoder. So that's the scalable approach on the previous slide. But you will do it not to get directly the answer. You will do it to get a long list of candidate documents, with the hope that among those you will have the answer. And after that, you use the cross encoder. So that's the first approach just on those documents. For the first part, even if you just have to compute just a scalar product or just compute a distance, that can be extremely time consuming if the set of documents is everything on the web. So to do that, you can use something called approximate nearest neighbors. So the idea is that you have a cloud of points in a very high dimensional space. Each point corresponds to one document, and you have your query, which is again one point in the same vector space, and you want to find the 100 or the 1000 documents closest to your query. And you would like to do that without comparing the query with all the documents, because there are too many of them. There are two ways of, there are many ways of doing that, but here I will shortly present two of them. The first one is called locality sensitive hashing. So you reduce the problem to a one-dimensional problem. You take your high-dimensional vector space, you project it on a random one-dimensional subspace. You do that beforehand. So for the documents, you pre-process all the documents, and you do that for several one-dimensional subspaces. And if you had 2 points that were very close before the projection, they are still very close after the projection. So you just have to pick the points that are very close on that one-dimensional on those one-dimensional subspaces. And you can so on that one-dimensional subspace, you can pre-compute bins. You check in which bin your query is, and you get all the documents that are in that bin. And if you do that for several one-dimensional subspaces, you just have to compute the intersection of all those bins. The other approach is called product quantization. So here you start again with your high-dimensional vector space. Then you split the dimensions into several groups. So you take the first 3 dimensions, then the next 3 dimensions, and so on. And for each, so you have several small dimensional spaces, and you do some clustering of the datum in each of those. And you could do that, and you could so split the coordinates in different ways in order to have some overlap. And the idea is that if you had points that were relatively close before doing the procedure, then they are likely to end up in the same cluster, or at least they will often end up in the same cluster. That kind of approach is already available in some databases. You have databases that contain that allow you to put vector embeddings. Another approach to do the same thing, to query a large to query a large number of documents is to try to compute a similarity matrix between all the possible queries and all the documents in your data. And you can do that with some low rank factorizations. So the idea is to take not all your documents, but take a random subset of the documents. You take a set of reference queries, and for each reference query, you will for each reference query, you compute the similarity between the reference query and the random documents that you have selected. And after that, when you have a new query, you just have to compute the similarity between the new query and the documents that the random documents that you had chosen, and that allows you to complete that to complete that row, to infer the similarity between the new query and the documents that you had not selected. I've already mentioned knowledge graphs, but when I mentioned them, that was these were actual graphs with nodes and edges, but we have a few other ways of representing the the knowledge. So we can so I mentioned at the beginning the vector embeddings. So for each word, for each token, we can compute an embedding, and if we do that, we notice that in some cases some relations are visible in the data. So here that's the same data as earlier. That's these are the first two principal components of the vector embeddings of those words, and we see that the gender relation seems to be always in the same direction. And we have also an age relation that seems to be visible. So we can generalize that idea. If we already have a set of entities and a set of relations between those entities, we can learn an embedding not just for the entities, but for both entities and relations. And in this case, relations could be translations. So they could be translations, but there are other models that use rotations or other transformations. A variant of that is to map entities not to points, but map them to regions, for instance, boxes, or to probability distributions. And that allows you to make some reasoning on those entities, for instance, taking the intersection of some entities. So I mentioned transformers. One drawback of transformers is that when you use transformers, you can end up with extremely large matrices, and you can be tempted to compress those matrices. One easy way to do that is just to take a low rank factorization of those matrices. The problem is that it's a relatively blunt tool. I think this is, yeah. So I think I'm running out of time. But the low rank factorization is a relatively blunt tool, and so instead of just computing a low rank factorization, you can compute a weighted low rank factorization with weights corresponding to the importance of each entry in the matrix. Since I'm running out of time, I think I will skip. Yes, I will skip a lot of things and go to the conclusion. So in conclusion, if you want to use if you want to use NLP in your own projects, I have listed here a few libraries, a few Python libraries that you can find, that you may find useful. If you're not familiar with NLP, I recommend you start with two of them, SpaceSim and Transformers. SpaceSim will give you all the standard natural language processing, so things like tokenization, entity recognition, and so on. And the other one is the Transformers library, which allows you to play with deep learning models. They provide pre-trained models for almost anything, so for sentiment analysis, for translation, and so on. You can check on their website. It's relatively well done. You can try even the models directly on the website. And I think this ends my presentation.
Thank you, Vincent. So this takes us to, last but not least, our final speaker for today's event, Gauthier Marty, who will be discussing the topic of using large language models in 10 lines of code. Let me just go to Gauthier's slides. That's it.
Thank you, Rhoda. So thanks, Vincent, for the transition. So far, we have seen a large language model from the research point of view and what was developed at TII with Dr. Ebtessam. Vincent also showed takeaways from advanced recent natural language conference. But what's for us mere mortals, right? Because all that sounds very complicated. And then Dr. Ebtessam says, OK, we should do startups, products. But how do we go from advanced research to something concrete? That's the goal of this short talk, or at least point you toward a potential direction. So before beginning, you can have a look at that. So there is a blog post that will basically say what I'm saying. So if you can't cope with my French accent, you can go there and look at the code. Maybe it's more clear. There is also a Google Colab. So if you're a Google account, you can duplicate and just run the code, and maybe it's even better. So once again, you heard this word a lot today, transformers. So they are complex models that power these large language models. Vincent did a great job to explain them. So probably now it's a bit clearer. If it's not a big deal. I'm here to show that you can still live with understanding these beasts. And yeah, the goal of this talk is really, can we do something without understanding fully the technical part? So one thing that I want to mention, it was also in Ebtessam and Vincent's slide, it's this Hugging Face website. So originally that was 3 French guys in New York trying to do a startup, a cool chatbot for kids. They shifted, now it's a big open source funded to do just code with hundreds of millions of dollars. And they are doing a library where you don't really need to know what a transformer is to use it. So as Vincent was mentioning, it can be as simple as so you have to pip install it. So you install it in Python, but from transformer import pipeline, you define your pipeline, which is your sentiment analysis. And then it's just passing a list of sentences to the pipeline and you get an answer. So the Abu Dhabi machine learning is so interesting. It will tell you it's a positive sentiment. But if you pass, after this event, I will have to do the course, then that's obviously negative. So here you are. I promise you 10 lines, but in 2 lines of code, you have already a sentiment analysis thanks to this library. Now, okay, maybe you have business ideas around this basic sentiment, but probably the interesting use case at ADGM or in other places, they rely on more specialized jargon. So technical discussion about law, finance, whatnot. So here I wanted to test a bit the limitation of this ready available model. So just to be clear, this has nothing to do with my current job or employer. If anything, it's stuff that I was working on 10 years ago about the credit derivatives market. So I pick up like sentences, market comments from portfolio managers that describe what's going on in their market. It's available freely online on their blog. And you see a couple of sentences that we will use to showcase the behavior of these models. So first sentence, which is supposed to be positive, in a decently risk-on section. So that's jargon to the, yes, it was bullish, good for markets. CDXIG, that's the name of an index, minus 2.8. CDXI yield, another index, minus 8.9. And in this market, when it's minus, it's actually positive. And then some more context, some CDS outperform the market. Tightening also, it's a jargon to say that the risk was going down. So, okay, some specialized jargon. Sentence 2 also positive, but if you are not familiar with fixed income, you may not understand. Bonds are also 75 bips tighter. So it means less risky in some sense. So the price is going up. So those two sentences are positive, and then next two are just factual, describing what's going on, and they are supposed to be neutral. So basically one company buying another, without more context, you don't know it. It can be positive, negative, neutral. And the last one, yeah, some company that is valued at such, and I know, some deal that will be paid half, 3/4 in stocks and 1/4 in cash. So that's this kind of sentences that you are facing. So it's a bit more complex in sentiment than what we've seen before. And what can these two lines of code get you? Well, garbage. So you pass them into this ready-to-use model, and basically you see that it got sentence 1, 3, and 4 wrong. So it thinks that the first one is negative. Was maybe he see the word risk. Oh, risk, it's bad, but actually it's risk-on, which means good. And also he says negative on 2 neutral sentences. So definitely you can just use this basic ready available model, but it won't help you to do something good for your use case. How to solve this problem? So we can again go back to the Hugging Face library. And actually, and that's the nice thing about open source collaborative research, there are people that are focusing on these problems, working and trying to solve these problems. So if you look for financial sentiment, because that's sort of what we tried to do before, you will find essentially these two models. So financial BERT, so this BERT model, transformer model, that was trained on financial document for sentiment analysis, and this other model that was done by a guy at HKUST that actually presented his model in a meetup in Hong Kong. And if you go on the website, you have a description even of what he did. So he trained that on corporate reports, 10K, 10Q, earnings call transcript, analysis reports. And look at the number of tokens. They are order of magnitudes lower than what Dr. Ebtesam did. She was mentioning 300 billion tokens. Here you are more 1 + 1 + 2, 5 billion tokens. But okay, you have access to that. So let's see what we can do with it. So once again, we are still below 10 lines of code. It's a bit more complex now. You have to import separately a tokenizer and the model. And then in the pipeline, it's sentiment analysis with the name of the model and the tokenizer. Once your pipeline is defined, you just fed it with the sentences and you get a sentiment. And what you will get is that it's again wrong. So you will find the sentence 2, for example, neutral, whereas it's positive. And why is it so? Simply because this model was actually fine-tuned and trained with a different sentiment in mind. It was with, in the perspective or the view of an equity analyst or a guy that analyzed corporate news release. And you see it was like manually fine-tuned and annotated on 10,000 documents. So poor guy, he has to look at 10,000 documents with positive, negative, neutral from analyst reports and most likely an equity analyst. So it's better than the normal model, but still it doesn't understand the bond or fixed income convention. So what can we do with that? So maybe you want to hire a guy to re-annotate 10,000 documents. That could be a solution, but painful one and costly one. So is it game over? Could be. I would have even thought myself a couple of months ago, yes, let's live with it. Maybe it's still enough for doing whatever we want to do. But actually not. So there is a relatively recent paper with a nice implementation again on Akin face. No, I don't have shares with them, but it's very nice. Called Set Fits. So the name of the paper is actually Efficient Few-Shot Learning Without Prompts. So the few-shot thing, what does it mean? It means, okay, you don't have to do 10,000 documents manually to fine-tune your model. And without prompt, because it's a different paradigm than what is used typically for doing a few-shot. But the small name, the shortcut for this paper is actually Set Fit, which means literally sentence transformer fine-tuning. So the sentence transformer, it's a different type of transformer than what we saw. It's a model that has been trained specifically to take one sentence in input and build an embedding. So that's what other models do, other transformer, but usually they do that such that the embedding, so the vector that Vincent mentioned, is fine-tuned for a classification task. Here it's different. Those models have been fine-tuned so that two sentences that are nearly paraphrased, very semantically similar, end up close to each other, which is not guaranteed by general embeddings. So that's what is a sentence transformer, and how we will use that is that we will do still manually a few annotation, a few labeling, but instead of 10,000, let's say 10 per class. So in our context, we say, okay, we have 3 classes, positive, neutral, negative. So that's 30 sentences to look by hand in some sense. So you will do 30 labeling by hand, reading the sentence, saying positive, neutral, negative. So 10 per class. And once you have that, you will build a new data set, extend it in this way. So basically, you will do triplets. So you loop over all the sentences. So you have 30 times 29 over 2. That's roughly what, 900 over 2, 430, less than 450. You have 450, let's say, to simplify examples. And basically, you have sentence 1, sentence I, sentence J, and a class that will be 0 or 1, or let's say in this case positive and negative, but it's not the sentiment. Just saying, are they from the same class? So if 2 sentences are from the same class, it will be 1 point in your data set that is labeled 1, same class. And if 2 sentences are not from the same class, so they are not from the same sentiment, then it will be 0. So what are you trying to achieve here? You are trying to modify, to fine-tune in the jargon of this community, the model, so that if he sees sentences from the same class, he will adapt itself, he will fine-tune, he will change his weights to say that they are actually close to be the same. If they are from different class, he will represent them with the embeddings wider apart. So I'm not sure if I'm clear, but basically the high-level goal is to say, to help the model to say those are the same sentences or those are not the same, and you will transform the latent representation in such a way. So we have built this small classification problem. We train it, and once we have trained that, what we do is we take again from the original dataset a sentence, we feed it in the sentence transformer, so we get a vector. And this vector, now we try to learn the class, so positive sentiment, neutral sentiment, negative sentiment. And this, we do it on the small data set of 30 examples only that we have. And that's it. That's our model. And after the inference time, it's what? You take a new sentence that you've never seen, you pass it in this pipe. So it means you take the sentence, you apply the sentence transformer, that means you have a vector, and you apply the classification head, which means then that you have the decision, positive, neutral, negative. So that's a 2-step, and concretely with code, it can be done this way, so very simple. You import set fit from again face. Then you load the base sentence transformer. So here the name of the model, but there are others, is paraphrase MPNet base v2. What does it mean? It's a sentence transformer that have been trained to say if two sentences are similar or not in meaning, so paraphrasing. That will be your base transformer. Then what you do is you build a small data set. So here it's 30-ish sentences where I said, okay, that's positive, negative, or neutral. So, you know, bond prices were down by a few points. That's negative, obviously. The CDS traded at its tightest. That's positive. And, you know, neutral. Over the last few sessions, arbitrageurs have done something, whatever they have done, that's neutral. So you have this 3 times 10 example. You pass it to this training mechanism that I explained, the 2-step. So first you fine-tune the sentence transformer so you understand synonyms in some sense, and then you feed the classification head. And here we are, the results. Yeah, so I didn't lie, that is less than 10 lines of code, right? 1, 2, 3, 4, 5, 6 maybe. So we are still well below 10 lines of code. And you can have a result where now you see that sentence 1 is indeed positive, sentence 2 positive, sentence 3 that was neutral, neutral, sentence 4 that was neutral is also neutral. And you can do it with sentences that are just invented, just to see if he understood the convention. So credit spread increased, so that's bad. You see negative, credit spread decreased, that's good, positive. Then you can see, for example, the company will release earnings next week, the next sentence that's neutral. And here you put also Elon Musk bought Twitter, which is neutral, but if anything, the model thinks it's a bit more negative. I don't know, it was some alpha or some self-forecasting, but yes. So that's it, very simple. So you can forget about this, you know, credit jargon, that's not so important. The main takeaway from this talk, it's if you have a domain specific that you know, like let's say legal or things like that, and you want to fine-tune a model, since I think the couple of paper is maybe 6 months old, but let's say for a couple of months now, it became very easy. And I think that will enable lots of application in practice. So that was it for my talk, short and maybe sweet, I don't know. And I think that's it for this meetup, and we'll have some time after for refreshments. Thank you.
Thank you, Gauthier. Still have a few minutes to take some questions, and just for our virtual attendees to know that Dr. Abtissam had another important commitment and she left the venue. However, we have recorded all the questions we received virtually, and we will share it with Dr. Abtissam and ensure that we address all the questions received. So we would like to start with some questions we received through the chat, to make sure that we answer as much questions as possible. So the first 2 questions I would like to raise are addressed to Vincent. So the first question was, how can we effectively handle ambiguity in natural language processing tasks such as parsing and semantic role labeling?
So that's a tough question. I'm actually not a specialist of NLP, so I'm not the best person to answer that. Quite often, the models that we have are probabilistic models, so they do not give a single answer. They will give a probability as answer. So if there is some ambiguity, you will have one answer with some probability, another answer with some probability, and other answers with negligible probability. So that may be one way of addressing ambiguity.
Vincent. And the second question was also from a virtual attendee who was asking, what are the challenges of natural language understanding and how can empirical methods help address them, especially in the financial field?
So the challenges of understanding would be so problems with ambiguous language, things like sarcasm or when you say something while meaning something else, and you implicitly assume that the audience will understand that, that's relatively difficult for language models, or that's a potential danger. So what was the second part of the question?
Can empirical methods help address them, especially in the financial field?
So in the financial field, I'm not sure that is much of a problem, because that would be a form of, what I mentioned is a form of humor, and we don't expect a lot of that in the financial field. I don't have a good answer. What I would do if I were faced with that kind of problem would be to try to find not one source of information for a given fact, but try to find several sources of information. And if they all agree, then I would have more confidence. If they disagree, maybe it's actual disagreement, or maybe it's a problem with the formulation. But having several different sources of information, different sources of data would be helpful.
Thank you. We also have rooms for questions. If anyone have any question, please feel free to raise your hand.
Yep.
Hi. Have you seen any kind of research or papers for either of the speakers around like deceptive language? So in theory, the sentiment is positive, but the intention is to deceive?
No, I haven't seen any example with that. That's a good question, but no.
Yeah, so to your point, not totally the same, but if you follow crypto and especially small coins closely, and you have heard about this large language model and ChatGPT. So before there were already some pump and dump, people trying to manipulate with rumors. But now it just lower the cost of doing this kind of manipulation. And yes, there are deceptive posts or rumors that are generative. And there is market manipulation this way for quite cheap nowadays. So that's yeah. So here we adopted more technological focus. Like okay, we are excited the technology is progressing, but definitely the cost of spreading wrong information is lower quite dramatically also, and there are consequences.
So we have one more question online, which is stating, how do we make sure that the selected sentences are exhaustive enough when using setfit? And similarly, how to avoid overlifting on the new sentences?
That's a very good question, and I don't have a precise answer for that. So their sort of marketing claim on their GitHub and the paper is that you can outperform proper fine-tuning the old way with thousands of documents with only a couple of such sentences. So 8 per class versus 3,000 is the example they give on their research paper. My experience that with 10 per class, as I showed, it works already. But it's very much an empirical question, and I don't have a clue, or I don't know how you would assess the fact that you are refocusing the model too much on the few labeled sentences. So that would require proper empirical analysis that I didn't do.
I'm just referring to the previous question somebody asked you, like, have you tried multi-step validation in parallel with the multi-step reasoning to arrive at the best answer possible?
No, I have not used that myself.
Okay.
This is a very generic question. I was hearing Dr. Abdesam, and she was talking about the dearth of Arabic content in internet, right? I was then thinking that because we already have an Arabic model, and it can be used to generate text. So can the generated text, the current model, generated text, can really be reused to retrain a better model? And if this is not just Arabic, I'm talking about ChatGPT-3 as well, because in near future, we'll be having a lot of generated text coming in from the ChatGPT. In future, if you really want to train a better model than ChatGPT-3, then how can we really be sure about that our data is pure and not generated from the chat?
I like this provocative question. So I think I'm not sure people have a clear answer or idea, but there is a fear, yes, that we will end up in a sort of fixed point. You know, you generate, you fit to what you've generated, and finally you converge to even some things that are wrong, and you think it's the truth. So that's, I think that's a societal challenge that is tied to many. It's like, will the generated data stay less pure in some sense, or should it be flagged? Or will we develop, and there are already models to detect what has been generated, but then there will be an arm race. You try to generate things that are fooling a detector of generation. So that's not clear. And something we didn't abandon there because it's not so much the nature of this meetup is, but it's also tied to your question is how do you reward? Like, you know, if I write a book thanks to ChatGPT and I get rich because of that, but it's mostly the work of many people that enter into that. So should there be a structure of micro royalties and to whom it gets? How do you find the people that indirectly contributed? So that I don't know, but I don't think it's clear in any people's mind at this point. How do you address all these important problems?
Text is already generated. The input engine takes it as a text, whether it is generated from ChatGPT or any other GPT for that matter. It takes it as a generated text. I mean, I don't know. That's what. That's how. Right. It assumes that it's the other form of text input which is coming into it, and that's how the previous ChatGPT handled as a what do you call as a data point or
yes, but after why it works, why it's better in some domains. So there is also a regularization through the many viewpoints to find what is true. So it's at some point, you know, Arabic model say the Earth is flat, and there is not so much content or contradiction. And then all the example that the model is trained with the Earth is flat, finally everybody will start to believe that the Earth is flat. Yeah. So that's a danger of repeating the method on itself.
That data pollution problem was already there, is already there. You have that, for instance, in Wikipedia. You have some Wikipedia pages that are generated automatically. For instance, pages about cities, they can be generated automatically. And when you train a model, you have to be careful to remove that because otherwise the model will be biased. But what you mentioned actually has a positive side as well. If you have a model, a powerful model, you can use it to generate data, and you can use that data to train another model. That other model will have much more training data than the original model, so you may be able to train a model with much fewer parameters, making it work. It will be much more efficient. For instance, you are more likely to be able to use it on mobile devices. So that's called knowledge distillation, and that was also mentioned a lot during the conference.
So when you talk, just raise it up.
Yes. Hi. Is it possible to take a pre-trained model that was trained on like English and to fine-tune it on another language?
Yes. Actually, yes, and that's so for ChatGPT that was more or less done. ChatGPT for GPT was initially trained not on English language but on computer code, and then they fine-tuned it on English language, and that was also done a few years ago with languages from Eastern Europe. So things like so languages like very similar to Russian. They trained the language on Russian because there was a lot of training data. And then they fine-tune it or used it directly for other similar languages. So that's a good thing to do, even if the languages are not very related, as ChatGPT shows.
But would you translate it back into English? Would you recover the original text?
In that case, there was no translation at all. In the examples I gave, there was no translation.
If you do translation,
Yeah.
would you
Yeah.
recover the original text?
No.
Or if you do
No.
English,
No.
Arabic, French, and
Yeah.
then from French go
Yeah.
back to English?
Yeah, no.
You would not recover.
No, so that's called back translation, and that's actually something that is used if you want to generate data to train a paraphrase model, a model that recognizes if two sentences say the same thing. So you take the sentence in English, translate it into French, translate it back into English. You have something different, but they say more or less the same thing. And you can train a model to recognize that they are the same thing.
I still have another question. How about the performance? Would it be better than training the model from scratch?
Usually, yes, that would be, well, you would have a head start, and the model will perform better, especially if you don't have enough training data. If you have an infinite amount of training data, it probably does not matter much. But if you have limited training data, so for low resource languages, that's important.
So also, like for training, so if you don't have enough resources to train big enough model,
Yep.
so just to take existing model and add something on top.
Yep.
So it would be much more beneficial, like let's say for your research and development, for example, projects. So instead of the training model from the beginning, it required like huge amount of resources, data, and so on and so forth. So if you take existing model and you would just add some, for example, domain in medicine or finance or whatever. So you can just add this on top with less resources, faster, and get some value.
Thank you, Gote. I think this takes us to the end of today's event. I would like to start by thanking our speakers for today's event, as well as our audience who are attending physically and virtually as well. And please allow me to invite you for some refreshments outside this room. Once again, thank you so much for your attendance. And on behalf of ADGM Academy Research Center, I would like to wish you all a blessed holy month. As I would say, we would like to be the first ones to wish you a blessed holy month, inshallah. Thank you again, and I wish you all a great evening.